Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Question 4 states that over a year's time, a person receives a biologically equivalent dose of 24 millirems from cosmic rays, which consists primarily of high-energy protons bombarding Earth's atmosphere from space. The RBE of the protons is 10. Part A of this question asks, what is the person's absorbed dose in rads? So based on what we've been told, the absorbed dose, if you remember the relationship between RBE, BED, and dose, obviously, of course, is the biological equivalent dose, is simply equivalent to the RBE times the absorbed dose times the dose. So we can rearrange this simply to have BED over RBE and that does again produce units of rads, so we don't need to do any other conversions other than converting millirem to rem. So it's 24 times 10 to the negative 3 rem over the RBE. Oops, sorry. Oh, that's 24, not 2.4. Over 10 to produce a absorbed dose of 2.4 times 10 to the negative 3. Rad, of course. Great. Part B of this question states that the person absorbs 1.9 times 10 to the negative 3 joules of energy from cosmic rays in a year. And what is this person's mass? So for part B, we're told this energy absorbed is 1.9 times 10 to the negative 3 joules. So if we're assuming that this person does receive this dose from part A, this amount of rad, we can simply find the mass, again, from the relationship of absorbed dose, energy, and mass to be the energy over dose, right? Because if we're given dose equals energy over mass, so just rearranging, we find that this energy is simply, the mass is simply energy over D. So we can substitute in our values. 1.9 times 10 to the negative 3 joules. But here, as we notice, our numerator has units of joules, our dose has units of rads. So joules and rads don't really mix, they don't combine well. What does mix is gray. So we need to convert our units for dose into gray such that they're in joules per kilogram, which would give our final answer in kilograms. So if you note, we can multiply this equation by that conversion factor. So if we want gray on our denominator, we have 1 gray here. And we note that there are 100 rads per 1 gray. So we simply just multiply our term by this ratio such that our rads cancels out. We have joules over gray. Remember, gray is joules per kilogram. So this is simply, we can think of it as joules per joule per kilogram. Our joules will cancel out and we're left with just kilograms, which is of course the unit we would like for mass. And by doing this calculation, we would find the mass to 2 significant figures to be 79 kilograms.